Welcome back, guys. So in the previous videos we covered electrophilic aromatic substitution, and we covered one reaction that kind of encompassed two called halogenation, and we covered how to add bromine to a benzene, which is just called bromination, and the same mechanism for chlorine called chlorination. Now we're going to talk about two other reactions called nitration. So we're going to be adding like these nitrogen groups, and sulfonation, adding these sulfur groups. Alright, so mechanisms are going to be similar, right? So let's get started. Let's see what's going to be going on here. So I left this whole little reaction scheme here for you guys. So if you want to maybe write that down or something because you have it before and you find it useful, please feel free to do so. So let's get started. So first one we're going to be covering is sulfonation. All right, sulfonation. So again, these all start out with benzene. Alright, so we're going to put a benzene over here, and we're going to write SO3 over H2SO4. So, what's going to happen here? So first we're going to start out with the SO3, sulfur, double bonded to 3 oxygens. Alright, now this isn't breaking the octet rule. Remember, sulfur is in that period that it can have more than those 8 electrons. So what's going to happen here is the benzene, and let's not forget there's always a hydrogen on those carbons unless otherwise shown. Alright, one of those double bonds is going to come in, attack that sulfur, and one of those oxygen double bonds comes up to the oxygen. So what we're going to have is this complex, remember? Here's the benzene. Our H. Now it's going to have, here's our sulfur, double bonded to 2 oxygens, and that O minus. Alright? And actually let me make that a little bit easier and less clutter. Alright, there we go. Now remember, we used up this double bond, so that doesn't exist anymore. And what's going to be left there is a positive charge. The other 2 double bonds were fine. They stayed where they were. And now we have like this complex again, right? I can resonate this double bond. Move this positive charge here. Our hydrogen and our sulfur group are still where they are, right? And again, we could do it. We can bring this down, but I'm not going to show that. You've seen it already right here. We're going to put this here. And so I'm going to just skip ahead. Well, actually, I guess I will have to draw it. Sorry. Okay, and so this is our, remember, sigma complex, or it could be called the uranium ion, or uranium intermediate, same thing. Now what's going to happen is we're going to have, remember, some sort of deprotonation, right? Because we need to restore that aromaticity. So this double bond collapses downward, and we're going to get this as our product. This is our new double bond. S, 2 double bonded oxygens, and that O minus. Now it doesn't stop there. Because we're in acidic conditions, we can protonate that O minus, right? So it's going to get a proton. You could write this, or like this, or take it from the H2SO4, right? I'm just going to leave it as a proton. Attacks that H, and the final product is going to be benzene. With that SO3, with that SO3H group. S, 2 double bonded oxygens, and this H. You could see it written as this. If you see this, it's the same thing. SO3H. Alright, sometimes we just write that just to save time because no one wants to write out that full structure. That's the same thing. So the summary of the reaction is going to be this: SO3 over H2SO4. Alright, and that's just going to give us this. Now, one thing about this reaction that is very important that you guys know, it's reversible. I can remove this SO3H group. Alright? Why is this important? It can come in handy when you're trying to add other things in the future. We can essentially block a position with SO3H, do the reaction, and then remove it if we don't remove it after we've done the reaction. Now, I know it means probably nothing to you guys right now, but we'll see it later on. And the way we reverse this is we write H2SO4 dilute. Alright? So make sure to put the dilute, and you're going to be right back to that original benzene. Alright? So that's the sulfonation reaction mechanism. Now let's move on to the nitration mechanism. Alright, so nitration. So how does this start? What are we going to write? So I'll show you guys the general scheme first. Benzene, HNO3 over H2SO4, and what that's going to do is it puts this NO2, this nitro group, on it. Okay? So that's the general idea of the reaction. Now what's going to be the actual mechanism for it? Well, to start out, the HNO2, sorry, HNO3, my bad, not HNO2, minus charge, plus charge. What's going to happen is it reacts with H2SO4. So this is H2SO4. Alright. This OH grabs one of these hydrogens and this bond breaks. That's going to give us this intermediate. That oxygen is going to get a plus charge now. Now, it doesn't like to have that plus charge, right? Remember, this is essentially kind of water on it. So we're going to get rid of that. So how is this going to happen? This O minus over here is going to donate one of its lone pairs to form a double bond. But that nitrogen, remember, that's going to be too many bonds. It needs to get rid of something. So it's going to get rid of this good leaving group. That gets kicked out. So we're going to get, water over there. And our new intermediate is going to look like this. Right? So you see, we essentially kicked this part out, right? And we kept only that. So we get this NO2 plus the nitronium ion. It's good. You should know that this is the electrophile in this case. We don't just go and straight up attack HNO3. The benzene is actually reacting with that NO2 plus intermediate. Alright, so here's our intermediate. Double bond attacks the nitrogen, kicks one of these bonds up, giving us this. We have this, and I'll just write it as NO2 NO2, and actually, hold on, H, positive charge now. Remember the double bond left. It's part of that NO2 now. It's attached to the NO2, right? And we can have that again, that, you know, that sigma uranium intermediate. I'm going to skip that part this time. I'm just going to go straight to deprotonation, and so we can have something like, you know, a base or water deprotonate that H. But the important part is that collapses downward, right, to form the double bond. So we're going to restore the aromaticity. So get used to that idea of aromaticity. That's the whole point of that deprotonation. We want to restore benzene's aromaticity. Otherwise, it's not going to be that stable. And the end result is this nitro group is now added onto the aromatic benzene. All right? And so that's a pretty cool reaction that we can do. And so, again, you guys are going to find that we're going to be using these a lot in the future, right, to add multiple substituents to benzenes. You're going to learn in the later videos, and obviously in a lecture, how groups already on benzene will affect these reactions. All right? And so that's going to be the end for this video. In the next one, we're going to be just finishing up these last few reactions, and then we can move on. All right? See you guys in the next video.